Hi guys, so this is J3 and we're going to be talking about things called accumulation functions. So here are the directions. You are given the graph of G above and the following accumulation functions. So the way that an accumulation function works, guys, is that it's defined using an integral, and the input of the function goes in the top endpoint of the interval. Okay, so yeah, so I'll just jump into it and then you'll see how accumulation functions work. So find the indicated function values. So we're going to find h of 7. All right, so this is h right here. So h of 7 is equal to the integral from 4 to 7 GW dW. Okay, so where the input goes of h is up in this top endpoint. So yeah, so h of 7 is going to be the integral from 4 to 7 of g, and this is the graph of g. And then from 4 to 7, this area under the curve is 8, so that answer is 8. All right, now let's do number 2. So now I want h of 10. So I'm using the same accumulation function. So h of 10 is the integral from 4 to 10 GW dW. And this is equal to the area under the curve from 4 to 10, so that would be positive 8 and then negative 10. So that's negative 2. All right, now I'm going to do f of 10. I'm going to use this one. So f of 10 is the integral from 7 to 10 GW dW. All right, so the difference in h and f is the starting endpoint. So now we're starting at 7 and going to 10, but using the same graph G. That area is negative 10, 4, f of 4, 7 to 4. All right, the integral from 7 to 4, that is a backwards. We're integrating over a backwards interval, so that becomes negative 8. Now 5. R of 7. R is this last one right here. Okay, so the integral from 10 to x. So the integral from 10 to 7. Okay, so from 10 to 7, we're integrating backwards. So this becomes, so this is already a negative 10. So this area is already negative, but integrating backwards makes it positive. So that would be positive 10. And then R of 4 from 10 to 4. Okay, so the integral from 10 to 4, this is going to be negative 10. No. This is going to be positive 10 and then negative 8. Because we're integrating backwards. Okay, guys, so that's how you evaluate an accumulation function. Now, we're going to do this part. Find the intervals over which h is increasing and decreasing. So h, guys, let's remember, is the integral from 4 to x, GW dW. So h is the function. So the function value of h is always the area under the curve from 4 to any value x. All right? So let's think about, different x's. Let's say like x is 1. All right, no. Let's say like x is 5. If x is like 5, the value of h, if you put like a 5 up there, so h of 5, the value of h would be positive, all right, because it'd be this positive blue area. And then as you plug in more and more x's to the right of 4, you're just accumulating. That's why it's called an accumulation function. You're accumulating more positive area. So as my x value moves closer and closer to 7, I'm just still accumulating this positive area. And then, guys, at 7, the area that we're accumulating starts to be negative, all right, and becomes more and more negative. So this function h, it's only increasing from 4 to 7. All right, it's increasing from 4 to 7 because that's the interval where you're adding more and more positive area. But then at 7, we start to add on negative area. All right, so we're adding on more and more negative area, more and more negative area, more and more negative area. So it's decreasing from 7 to 10. Okay. Alrighty.